Colonoscopy, or lower gastrointestinal endoscopy, is a medical procedure whereby a healthcare professional displaces a flexible endoscope along the large intestine to perform examinations or even interventions. Reaching expertise in this type of interventions requires that apprentices learn the elaborate choreographic movements to control the endoscope, usually with real patients under the tutelage of an expert. Such training methods hinder the learning process, as hundreds of training procedures are needed prior to achieving expertise. As a response to these learning needs, new training solutions have been developed, among which the simulators stand out with 4 categories: in vivo, using mainly live swine; ex vivo, using animal organs mounted in physical frames; mechanical, mainly plastic or rubber organ models; and computerized, physical devices with embedded sensors to capture and reproduce endoscope movements in a display. Despite the benefits of using colonoscopy simulators being more apparent over the last decades, each category has its own drawbacks. Issues about availability, either because of time, space, or cost limitations, the reduced sets of training scenarios, and the need for tutelage during training are the main issues of current simulators. This work in progress presents a virtual training environment, LOGIVIT, or Lower Gastrointestinal Virtual Trainer, as a solution for colonoscopy training. The current prototype is a desktop experience with gamepad or mouse and keyboard control. The final version will be a full VR experience to provide the visual fidelity and haptic feedback required to reach higher degrees of user immersion. LOGIVIT aims to complement current training methods while providing key benefits, such as file availability without time or location restrictions, an improved low-cost training experience with almost unlimited training scenarios thanks to the procedural model generation, an improved training engagement with built-in guidance and support for users, and the possibility of developing and sharing training scenarios to support the medical learning community with our open source project. As commercial simulators have privative rights over the software solutions, research of current state-of-art and interviews with colonoscopy experts were required to set the basis for our physics, modeling, and user interaction solutions. Following a SCAM methodology, our development process consists of integrating our custom solutions in prototypes to be tested and evaluated by endoscopists, in an iterative process of continued improvement. This leads to our current prototype, where the main issue of creating procedural models and allowing the creation of training scenarios was assessed. Such training configurations allow defining diseases, their severity, and the affected segments along with the intestine and endoscope model to use, while being exchangeable between users. A first approach to a guided endoscope was also developed, where the user can move through the intestinal tract over a predefined path. Providing control over the camera rotation, zoom, or position in the path allows the user to obtain an easier method for tract exploration that can be used in disease recognition training. Non-guided exploration was also tested by developing an endoscope model with free movement through the intestinal tract. Physics, mainly collision detection, and the resultant deformations between endoscope and large intestine were also tested based on Unity and SOFA physics integration. A built-in editor for creation and editing of large intestine models was developed based on the procedural generation solution. This editor provides the means for an easy configuration of intestinal models that can be exchanged between users along with a training configuration. Regarding the future of this project, the full integration of physics and added editing functionalities for intestine models and training configurations will be assessed. Guidance and support features will be also developed to be used after the establishment of control test groups for the prototype evaluations. This is LOGIVIT. Thank you for your attention.